and welcome back to the HBC Brewhouse. Our last lesson covered everything up to the point of boiling, and as I said in our first slide of this lesson, we're going to talk about the cold side, which is everything that happens after we stop boiling. So if you've gone through your slides, you'll have seen I posted a couple videos about some of what we do here. It's a lot easier to do it that way than try to talk to a camera as we're trying to brew. So make sure you definitely pay attention to the videos in those slides. Something that I'd like to cover in more detail here in this video is, if you've watched those slides, you may have seen our inline oxygenation, and what that video doesn't do is really give you a good idea of how that's all put together, that whole contraption. So we're going to do that now. We have here our small oxygenating Carb Stone. This, if we could look at it under a microscope, has millions of tiny little microscopic holes in it. We're going to put our oxygen through this fitting. It's going to come out through our Carb Stone and create millions of microbubbles to oxygenate the wort as it flows into the vessel. And the whole point of that is to make sure that the yeast have that oxygen in order to produce the lipids necessary for their cellular development as they reproduce, but we're going to get into that a little bit later in our yeast class. So, we're starting with our Carb Stone. To that, we're going to be adding our silicone gasket, put that over the top, and then we have our tea. Our tea goes over the Carb Stone, and we're going to put that together with our tri-clamp. We're going to add another gasket on top, and then we have our sight glass. Hold that together with another tri-clamp. And there is our oxygenation assembly. So, again, the gas is going to come in through this fitting. Our cooled wort is going to come in through the top of our tea and hit that Carb Stone, which is producing millions of little oxygen microbubbles, and all of that liquid is going to be flowing up through our sight glass. Is the sight glass necessary? Technically, no. But you want to be able to see what your microbubbles are doing. That's going to, if at our scale we don't have an oxygen flow meter, so that's what's going to tell us about the oxygenation level of our cooled wort. This is now ready to put onto our fermenter, and we're ready to roll. So, now that we've got our oxygenated wort inside our vessel, we're going to pitch our yeast. So you want to make sure that your that your wort is at the proper temperature for your yeast. Every yeast has a different pitch temperature and a different temperature at which it ferments. So definitely make sure you know what your yeast is capable of handling before you do this. I know that Joey will be going into pitch rate and more details about yeast, so I'll skip that part. And we're going to cover a little bit of fermentation here. So, we've pitched our yeast, now what? For the first 24 hours, you're not going to see much of anything. This is called our lag phase, and what's happening at this point is the yeast is waking up, adjusting to its environment, and it's starting to get the lay of the land in terms of what's available for it to eat. That puts us into our exponential growth phase, and depending on your yeast, this phase may last from a couple days to a couple weeks. Lagering, it takes a little bit longer. Generally speaking, the warmer your fermentation temperature, the faster your exponential growth phase is going to go. And you're going to see this in the form of lots and lots of bubbles and activity in your blow-off bucket. Yeast have eaten all the available sugars in that liquid. They're going to start falling asleep. They're going into their stationary phase. All this means is that they are starting to flocculate out of suspension, and if you just left them alone on their own, they would all slowly flocculate to the bottom of your vessel. We need to speed that up. What we're going to do is drop the temperature of our vessel, and the way we do that here at HBC is through our glycol jackets. We're going to drop the temperature to about 33 to 35 degrees, and all that's going to do is speed up the process of the yeast falling out of suspension. They're all going to flocculate to the bottom of our vessel, into that cone, or we can draw them out. Generally speaking, we give the yeast about 24 to 36 hours to flocculate out of suspension before we attempt to pull that yeast. Some yeast take a little bit longer. It just depends on the strain you're using. So once we pull that yeast out, we are ready to carbonate. In some breweries, you're going to be able to move that beer over to a bright tank, and that's where you're going to do your carbonating. Here we have the uni tanks where they're able to hold more pressure than your standard fermenter, so we're able to carbonate inside the fermenter. I should say here that no way is better than the other. For us here, we just have less space, so it works better for us to not have bright tanks. So these are our carb stones that we have inside the fermenter. You'll notice that they are considerably larger than our oxygenating assembly stone. And all this does, it just gives us more surface area for the carbon dioxide to come out. It works just like the oxygenating stone. Gas comes in here, comes out here as microbubbles. And the fact that it's longer just allows us to produce more microbubbles faster in the liquid. The cool thing about having dropped the temperature already is that you want to make sure that your beer is nice and cold before you start carbonating, because it helps the carbon dioxide bubbles disperse fully in the liquid. I can tell you from personal experience, if you carbonate warm beer, it will lose carbonation and you will end up serving flat beer, and no one's happy with that, so don't do that. So now we've carbonated, we are ready to package. I included video at the end of the slideshow about how we can, so definitely check that out. So we're going to can some of this, and we're also going to keg the rest. So this is our quarter barrel keg. It holds 7 3/4 gallons beer. I break down for you in the slides how much beer that equates to in pints and 12-ounce cans, so definitely check that out. That will not be on the quiz. But all you need to know is you've got beer in your keg. Now how are we going to get it out? So if you were able to open up your keg, you would see a nice big aluminum vessel, and in the middle you have a spear. There's the end of your spear. And this is a Sankey D, which all that's doing is telling you what type of coupler you need to get that beer out. So the beer is coming up through this tube, and you're going to get it out using your coupler. So pretend this has a hose attached. Just give it a good twist there. And now you're ready. Your CO2 is going to come in through this tube, and you're going to get beer out the top and into your glass.